as I'm sure you are all aware of by now, the industry standard for the storage and handling of anhydrous ammonia was updated in 2014. As soon as that standard was published, it became the industry RAGAGEP, or recognized and generally accepted good engineering practice, and an expectation by the EPA for industry to adhere to it. The agricultural industry is all over the board in terms of its willingness to meet this standard. In some cases, companies had very little to do to meet the new requirements because they were ahead of the industry standard published in 1999. In other cases, companies had and still have a large uphill battle to face and serious expenditures to meet these expectations. In this month's webinar, we will hit the main requirements of the current Compressed Gas Association standard. First, let's begin with the bulk tanks themselves. All bulk tanks must have a legible data plate. On that data plate, you want to look for a national board number, in which case you can go online and order the U1A form, which is known as the manufacturer's data report, sometimes called the tank's birth certificate. If there is no national board number, which happened in a lot of cases with these agricultural tanks, further testing will be required. If there is no legible data plate, or if no U1A form can be located, the company will need to conduct tests to determine the missing information that will be provided on the U1A form, such as metal type, thicknesses, welds, etc. This can be done through an API inspection or through an inspector recognized by the National Board Inspection Code. The important thing to remember is to talk with your inspector and let them know what you need before they conduct the work. The 1999 ANSI standard stated that the saddles shall extend over at least 1/3 of the circumference of the tank. The updated version replaced the shall with the word should, which means that it shall cover 1/3 unless you prove that it's adequate and a professional engineer conducts the calculations and signs off that what is in place is adequate. The idea behind this requirement is for a few reasons. First and foremost, it is about the weight distribution of the vessel and the surface area that the weight is distributed over. The other reasons are for protection from the tank rolling off in a tornado or an earthquake, and many times there are ways to improve these saddles to meet this requirement. But in any case, it must be substantial enough to meet the reasons for the requirement. Another requirement for the containers and appurtenances is that they should be located with suitable barriers to avoid damage by trucks or other vehicles. The main idea here is that collision protection is there to prevent incidental contact from vehicular traffic around the plant. So keep this in mind when setting those concrete blocks or driving posts into the ground, how far away they should be from the tank and how high they should sit. At the point of transfer from the transport load and the bulk plant, there must be a means of pull-away protection. Most commonly, this is referred to as a bulkhead. There are many ways to accomplish this with different types of valves, but the bulkhead must be substantial enough to remain in place in the event of a pull-away, and the piping and valves should be threaded into the bulkhead so as to serve as a weak or shear point. An excess flow valve, back check valve, or an emergency shutoff valve should be within 5 lineal feet of the end of the piping where the transport hose hooks up. Remember, the idea here is to protect your plant and the chemical from escaping your plant in the event someone else's driver makes a mistake and pulls away. In addition to the protection at the bulkhead, it is a requirement to have protection at the belly valve of the tank. An internal excess flow valve must be installed inside of the tank with a manual shutoff valve below that. Nearly all plants have had this for quite some time, as it was a requirement of KDA to have these installed by 2011. In both the liquid and vapor lines, an emergency shutoff valve must be installed to help protect the plant from a complete release of anhydrous ammonia. Most plants have this on the liquid lines, but were never installed on the vapor as well. There are many different styles of emergency shutoff valves. Of the most common is the emergency pull cable type. There's nothing wrong with this, but over time the cable stretches and when pulled will no longer activate the valves. If you utilize these systems, a protocol should be developed to test the cable every so often to ensure it activates. Another style is a push button that is activated electronically, pneumatically, or hydraulically. These are the best types of systems because the push button can be located in the office so that the emergency shutdown can be activated from a safe distance from the tank. One of the most important upgrades you can make for the protection of your employees is the installation of pull-away protection at the risers. There are several methods or styles to do this, and each has its own benefits and drawbacks. The first is a single-use style of breakaway, which means that once a pull-away occurs, the hose cannot be reconnected to the riser. Procedures must be developed to bleed down the hose before removing it from the tank it pulled away from. Another option is a breakaway valve that can be reconnected after a pull-away event. Again, with this type, procedures must still be developed to bleed down the lines prior to reconnecting the hose so as not to injure anyone by attempting to reconnect with a pressurized line or hose. The last option is compliant, though it's not the safest. This is a weak point, much like the bulkhead, where a shear point is located and an excess flow valve, backcheck valve, or emergency shutoff valve protects the plant side. We would highly recommend that you use some form of breakaway valve and not this last option. In the 2014 edition of the Compressed Gas Association Standard, there's now a requirement that discusses underground piping. This requirement simply states, underground piping shall be evaluated at a minimum of every 5 years to ensure leak tightness. This means that you can develop an SOP involving pressure gauges and pressuring the system up to ensure that the underground piping is not leaking. It's as simple as that. When PSM becomes fully enforced by OSHA and EPA, this will be their least favorable option. The most viable option to them will be conducting an API 570 test on the piping to ensure its integrity. While doing the tests on the vessels, it is not much more hassle nor much more expense to go ahead and do the testing for the piping and have it all completed at once. These requirements are recommendations that have been made for years by safety professionals throughout the industry, and they just make sense to ensure anhydrous ammonia's safe use. If you find yourself seriously behind with these upgrades, you may want to take the time to consider moving your plant to a safer location that is further away from a populated area and starting fresh. As always, if you continue to have questions regarding anything with your ammonia plants, contact your Ag Services or KFSA Safety Director for guidance. Thank you for your participation in this month's webinar.